Assalamu alaikum wa rahmatullahi wa barakatuh. Finale, last chapter, chapter 14, maintenance information system. Actually, maintenance information system, it is عود على بدء. We finished the project from identification selection, initiation planning, analysis, design, implementation. We move the project to the production side, we give it to the customer, and now any maintenance, any change, any modification to the system, we will cover it in the maintenance information system, chapter 14. We're going to cover in this chapter what is really the maintenance definition, process of the maintenance, what types of maintenance, there are many different types, and what is the cost of the maintenance phase. What we are going to, the objective of this chapter, this lecture and the lecture, second lecture, explain and contrast four types of system maintenance, describe several factors that influence the cost of maintaining an information system, and apply these factors to the design of maintainable system. Describe maintenance management issues, including alternative organization structure, quality, measurement, process of the handling change request, and configuration management. Most of these, it comes, in lecture 2. And finally, explain the role of case tools in maintaining information system. Well, we are going through the cycle. So we did the planning, analysis, design, implementation. We finished the project. We close it. And the people who work on the project, they've gone back to the company to another project. And maintenance, it's really a new project. So it is part of the system development life cycle, the life cycle of the project or the system. But the development ends in the implementation, in the installation. When we install it, the development is done. But the maintenance, it's عود على بدء. And we have to do in the maintenance, again, we have to identify what we want to maintain. We have to plan for it. We have to analyze it. We have to design it, change everything. Actually, planning, analysis, we are going to change the document and the programs. And we have to implement it. We have to write changes in the program. We have to do the test, etc. And then we have to install the change again. So the activity here is maintaining maintenance, obtaining the request from the customer, transforming request to changes, design changes, and implementation of the change. Well, as we said, maintenance phase involves making changes to the hardware and software and documentation of the system in order to support its operational effectiveness. It will include making changes to improve a system performance, correct problems, enhance security, or address any change in the user requirement. So we have to follow a process, which is a process of maintaining information system. Process of maintaining, returning to the beginning of the SDLC, which is عود على بدء. We have to start again from identification through installation in the maintenance. Process of returning to the beginning of the SDLC and repeating development steps, focusing on system change until the change is implemented. Maintenance is the longest phase in the SDLC. What do you mean by the longest? Because probably we develop the system, the project in a few months, maximum a year. But the maintenance, it lasts for years and years and years until we decommission the system, we throw it away, and we change it, That's why we talk about it's the longest phase. The development is done. Now we start maintaining. Probably, you stay maintaining 10, 15, 20, 30 years, we keep changing the system as we used to do it before in the legacy system, but nowadays with the technology, whatever, probably it won't last more than 10 years. Well, as we said, what really the major activities? First of all, we'll get the request from the customer. The customer need to change the system for many different reasons. And we see that we'll find out what are the reasons, or which it is, what type of maintenance we are going to do shortly. Then we take these and we transform it to a changes. We'll take the request and then we'll try to analyze it, find out how many program involved, how many databases, what kind of change, how long it takes, etc. All these things, which it is like the planning and the analysis phase here. Analyze it, we plan it, we estimate how long it takes, how much it costs, etc. Then we go into the design the changes. We design the change. If there is a change in the design, the database and the forms and all these, the logic of the programs, we made all the changes, there, and then we implement the change through implementation, coding, testing, inspection, and installation. Well, usually the customer, issue and we call it system service request or customer service request, SSR or CSR. We used to call it back, in Detroit Diesel, General Motors, we used to call it customer service request because the request it comes from a customer. He felt, it's a free form actually. The name, the department, the date, etc., and then what type of request to change and another explanation. This is just initial request, because after, we receive this one, we go and we try to discuss and find out more what really involved in this request, and after that we start analyze it and to find out, which program involves, how much it costs, etc., as we said just early now in the. So it is really a free form. You could. The problem here. Usually the customer does not know what really he or she wants, or even if they know what they want, they know it in an abstract term. They cannot actually relate to us. They cannot really write it and send it to us because they talk, the customer, they talk in their language. We used to have, and probably now, we used to have, some people who work, we call it liaison, like between us and them, between technical people and the business people. We used to call it business system analyst. We put one technical person in the user area. They help them in writing CSR, helping them in calling us and, in any technology or any technical term or anything, which it is help the customer to take information from us and relay it in the business and take it from the customer and give it to us as a technical people. What are the deliverables and outcome here? Maintenance phase of the SDLC is basically subset of the activities of the entire development cycle. Which it is, and deliverable, it is really like a new program, a new documentation. That's what really the deliverable, We take all the requests and we transform it, we change it to a program, we change the program, we test it, we change the document, which it is, we come up with a new program and document. Well, as we said, deliverable and outcome from the process are the development of a new version of the software and the new version of the design document created or modified during the maintenance effort. So we come up with a new program and document. Well, if we look at the maintenance process, the 4 bullets there, obtaining maintenance request, then we take that one in the planning to decide what involved, how long it takes, how many programs involved in that, how many databases, etc. Find out, the cost. Then to go transform request to changes, it is in the analysis. We find the program, the changes, all these kind of things, and then the database change, etc., whatever. Then we go to the design changes, which is 3, and implementation, it goes in the implementation. So like each bullet really related to one of these phases, then which it is, maintenance activities parallel those of the SDLC, which is it's the same as the SDLC: planning, analysis, design, and implement. Well, as we just defined it earlier, maintenance is changes made to a system to fix or enhance its functionality. It involves making changes to hardware, software, documentation to support operational effectiveness. It should include like make changes to improve system performance, correct problem, enhance security, or address any user requirement. Well, corrective maintenance, it is a task performed to identify, isolate, and cure or correct a fault in the system, which it can be restored to an operational condition. This, we take the system, we correct it, we do a remedy on it, rectify it, and apply that change to the system in order to make it operational again. Change made to a system to repair flaws in its design, coding, or implementation. Adaptive maintenance, it's an implementation of changes in a part or the whole system, which it has been affected by a change in its environment, change in process or whatever. So we need to do that change. Changes made to a system to evolve its functionality to changing business need or technology. Actually, it is a modification of a software product performed after delivery to keep the software is usable in a change or changing environment. The environment change, a new request or a new process we need really to adapt, we need to have, so we adapt the system to fulfill that new process. Perfective maintenance, it's a change made to the system to add a new feature or to improve performance. In other words, it involves making functional enhancement to the system in addition to the activities to increase a system performance, even when the change have not been suggested by a fault. When it is not suggested by the customer, you want to just enhance it. You want to really make it perfect. Well, preventive maintenance, changes made to a system to avoid possible future problems. It's regularly performed on a piece of equipment or a piece of the system to lessen, تخفف من, تقلل من the likelihood of that system to fail. It is performed while the system is working. The system now is working, but we are worried about the system, it will break in the future. So we fix it to prevent that the breakdown unexpectedly. The best example I always talk about, it is the year 2000 fixing. Back in the 90s, mid-90s, 95, 96, whatever, most of the companies start changing their system to prevent their system from breaking down in the first day of the year 2000 because of the date problem that time. Well, this chart will show, how big is, a piece of all these four types of maintenance. Usually the corrective maintenance is really, it has, most of the pie here. Preventive maintenance, it happens, once in a while. Perfective maintenance, again, it has really some. Adaptive maintenance, probably now it is bigger because there are many different changes to the business, because this is a survey long time ago. It's around 15 years ago or so. Well, since you know the maintenance, it is really going through the life cycle, through the development cycle from planning till installation, it will be costly. Why? Because you know, you have a program, you have to figure out what's really in that program and try to fix it. And here it comes, you know, the non-functional requirement, which it is the system must be easy to maintain, maintainability. If we really design the system in a structured way, in a way we make it easy to maintain, which it is the definition, maintainability is the ease with which software can be understood, correct, adapt, and enhance, I believe will reduce the cost of maintenance a lot. If we look at these figures to show us the cost of maintenance, if we look at the solid line, which represents the new development, back in the 60s and the 70s, when we don't have a lot of a computer system that time, the new development, it's a lot, it costs a lot, but there is nothing really to maintain. That's why you see the dotted line, which it is represent the maintenance, it's very low. By the year 2000 plus, 2010, 2000 till now, as we always saying that we don't have anything really for a new development. Most of our system nowadays, it is really maintenance. Because the maintenance, it covers a lot of things. As long as the idea, it is already exists manually, or it is written in an old system, whatever, and you want to change it, that's not really new development. We have, you know, a definition actually for a new initiative in the project management. We talk about, you know, the new development or the new initiative. It is when you have the idea and the programs in you. But if the idea it's already exists, and even if you do it manually, if you want to convert it, it comes under maintenance, conversion. You convert it from a system to a system, from technology to technology, from manual to computerized. But you don't have really new development to it. That's why the new development, it goes down in the latest year, and the cost of the maintenance, it go up high. Well, there are many different factors, you know, influence system maintainability. Latent defects, any defects, you know, happen to the system, any change to the system, it probably will add more defects to it, you know, because as we always saying, software, it's always affected by the modification. Number of customers for a given system. If we have a lot of customers who use the system, it will cost us more. Quality of the system documentation. If we don't have a good documentation, the maintenance, it will cost us more. Maintenance personnel. If we don't have skilled people, you know, who's really the maintenance, again, because if you don't have a skilled person, the person will modify a program which it is really make the program again, and will fix one problem, probably it will create two. The tools, if we have a better tool, again, we reduce the maintenance cost. Well-structured program, again, if it is really written using standardization, well-structured program, it will reduce the cost of maintenance. Well, when you look at the cost, and this figure, it shows, you know, the cost of maintenance and the impact of a good and the quality documentation to reduce the cost of maintenance. And as we said at the beginning, you know, the cost of maintenance is 60 to 80% of most companies. They put budget to the, you know, to the maintenance effort. This means, I believe, having a good documentation, what has really a very good impact on the maintenance to lower really the cost of the maintenance. If you see, you know, if you have a poor documentation, how much the maintenance goes up to 400. But if you go down to the average, or you go again in a good documentation, technical quality documentation, they are high, you see how really it will reduce the percentage of the maintenance very, very low. By this, we finished the first lecture. We have the final lecture in this semester and in this course. It will come soon, See you. Bye.